welcome to Tutorials. This is Tudor, and we're gonna do today part 5 of building your own cryptocurrency trading bot. Today we're gonna talk about order management and data persistence. So far we wrote a lot of code about our bot, code that allowed us to get data from Binance, to create some indicators and have some strategies on certain pairs. We were able to plot and backtest those strategies, and we were also able to place orders on the pairs that we chose to. Now what we're going to do is put all of this together into a loop that's going to automatically take data from Binance and check the different pairs for symbols on the different strategies that we select, and when a symbol arises we're going to be able to automatically place an order. Now once that order is placed, we're gonna also want to place another order that's gonna exit for a profit, hopefully, if not for a stop loss. So we're gonna write all that code that makes all of this magic happen. And also the data persistence part is going to allow us to save all the orders that we've placed and all the pairs and all the bot settings in a database, so that if the bot stops running for some reason, when we start it up again, it doesn't have to start with a clean slate. It's gonna be able to remember all the information that we stored into that database. So I'm gonna write all this code and I'm going to explain it to you today. So if you're interested, check this video out. Hey everyone. So I'm gonna try something new today. I'm gonna try and voice over my coding, and so I can explain things. So yeah, let's see how that goes. Going on to the Binance class, we're going to write a bit of constants at the beginning. These constants relate to the Binance exchange, so every exchange would have their own constants. We're adding a few extra endpoints, and instead of having the API keys stored in the Binance file itself, we're going to have a way to just input an external file and read from it. Now most of the time we get some data from Binance, or we post some information to Binance, we're going to pretty much write the same code. So I'm just writing two functions to handle with that, so that we don't have repeating code. Now here we're going to get the account data, and why we do this is because we want to know the balances of all of our coins. We're writing also another place order function, which will take a dictionary directly, so we can more directly call the function as customized as we need it to be. Now here in all these timestamp objects, in the params object, in all the timestamps, we're gonna add a request delay. Now what that does is doesn't delay the request, but it just tells Binance that we've sent this request later than we've actually sent it, because in the past I've had some issues with requests being not fulfilled because the internet was too slow. So I had to trick Binance into thinking that I've actually sent that request later than I really did. Now onto the strategies strategies.py file. I'm going to just let these strategies be individual functions, so I'm not going to put them in a class. And now we're going to write a very simple, very well-known strategy containing the 50 and 200 EMAs. So basically when they cross over, we either buy or sell. So when the 50 EMA crosses over the 200, that would be a good time to buy, and when it crosses below, that's a signal to sell. Of course, being a very simple and widely used strategy is not going to be very profitable, but depending on the parameters, depending on the time frame, it might actually be profitable. But anyway, the point is not to have profitable strategies, but to show you how you can have an infrastructure that allows your own strategies to be traded. So as you might be aware, I haven't really gone into how to create profitable strategies. I've just showed you how to build everything around strategies and those strategies, and also I've showed I think I told you how to create your own strategies as well, so that might come later on, but hopefully you also have some insights into building strategies. Now we're gonna write the database code. So using SQLite 3, it's a really useful library for Python. And again, in the database, we're going to have three tables: bots, pairs, and orders. And for example, in the bots table, we're gonna store all the different bots that we might have running, we might have created, and all their settings. For example, the name of the strategy that we're using, the interval, the take profit, target, and so on. For pairs, each bot will have a bunch of pairs, and for each bot we're gonna save how much profit that pair has made, and so on and so forth. And for the orders, each bot will have a bunch of orders, and we're gonna save all of them as well. And for all of these three things, bots, orders, and pairs, we're gonna write code that enable us to create a new entries in the database, retrieve bots or orders or pairs from the database, and update them, and also delete them. All right, next is going to be the BotRunner. This is where we're gonna write all the code that allows us to run these strategies in parallel. Yaspin is an interesting library. It's gonna allow us to send messages to the command line. This entry order function, given a pair or a bunch of pairs, is going to allow us to check a strategy on those pairs, and if a strategy matches, then we'll place an order. And because we've updated Binance to accept a placing order function that accepts as parameters directly the dictionary, then we can do what we did here with the order params. Some of the functions that we're using here are not yet written, but they're gonna come soon. For example, the self.placeOrder actually places the order on Binance, and it returns false if the order was not successfully placed, or it returns what the request itself returned. Exit order, what it does is it checks a given order. So all the orders that we've placed already are going to be saved in the database. Exit order checks all the orders saved in the database to see if they're fulfilled. Now, if an order was fulfilled and it was a buy order, that means that it was an order that we once we received the signal on a pair, we bought that coin, and now that order is fulfilled. So that means now we have to place an order at a higher price point, a sell order, to take profit. Now, if the order that was fulfilled was a sell order, it means that we've successfully exited a trade for a profit. We're not using stop loss in this scenario, but it wouldn't be hard to implement. As you can see, we're saving the orders in the database. There are a lot of things going on here. I'm not sure if this is the best format for me to transfer this knowledge to you. But yeah, maybe there's a different way. I'm gonna keep trying to experiment with it. The two functions that we just wrote are sort of similar. Only one of them returns true if the request was successful. The other one returns what the request actually sent back to us. This particular function transforms an order that we received from the exchange, or that we sent to the exchange rather. It transforms it to a database friendly format, so we can save it in the database as well. Now this is the function that actually creates a bot, given a few settings like the name of the bot, the name of the strategy we're going to imply. We're going to use the interval, how much we allocate per trade, and so on and so forth. So it's going to create a bot object. It's going to create a dictionary holding all this bot information, and it's going to save that dictionary in the database as well. And using these parameters, we're going to be able to run the bot. As you can see, for the bot, there are also a bunch of symbols, a bunch of pairs. So we're also creating a dictionary for each of these pairs, and we're going to save all of those pairs in the database. Now this function, as you can see, it gets a bot from the database. And this function gets all the bots plus for each of the bots all the pairs that those bots trade. This function returns rather all the balances from all the coins that we trade against with a given bot, because if, for example, we don't have enough available balance of BTC, let's say, then we're not going to check all the pairs that are trading against BTC, because there's no point in checking for signals if we don't have the balance to make trades. So that's the point of this function. So actually a bot object in this case is a tuple between the bot parameters and all the symbol data of all the symbols that are traded for that bot, right? That's just how how I wrote this one. So basically while true, so we're in an infinite loop, we check for all the bots, we check the strategy, we check the symbols, and if symbol rises, we're gonna place orders and stuff like that. So yeah, this self.run function, this is the one that actually checks for the symbols, for the signals, sorry, and this self.exit is the one that checks for the all orders to be closed. And I wrote it like this because I'm actually parallelizing the code. So instead of running it individually or over all the pairs, we're actually creating 4 threads that run in parallel on different pairs so that the process is much faster. So yeah, there you go, something nice here as well, how to parallelize some functions when you have to do the same thing for multiple different inputs. In this case, the inputs being the pair data, so the candlestick data. And this is the main function. So as you can see, we're calling the exchange using a file called credentials.txt. So in this file, we're gonna hold the API key and the secret key. The first row should be the API key, the second row should be the secret key, and then we're calling a database object, and we're giving it, we can give it any name. If the database object doesn't exist already, it will create it for us, and if it exists, it's just gonna use that one. So it doesn't matter what name you give to the bot database as input. And we'll have a little command line interface. It's gonna ask us whether we want to create a new bot or start from scratch. We're gonna create a bot that uses all these symbols. The strategy name is MA_crossover. This is gonna actually look into the strategies a dictionary from the strategies class, from strategies.py, rather py, sorry, not the class because we removed the class, but the functions are still there. and it's going to use that strategy to find the signals. Hey guys, how's it going? Let's run a demo and see how this bot is working. Oops, not this one. See how the bot works so far. Alright, so we have the code right here. We have the credentials. I showed you how that looks like. You just have 2 lines. This is this API key, the secret key. We have a database right here and all the other files. So now let's run BotRunner. I don't actually think I have any crypto on my account to trade, but I'll just show you the gist of it. It should, if you have coins on your account, you should be able to actually trade. Okay, so I'm gonna create a new bot. Yes, I already have bots in the database, but I'm just gonna create a new one so that you see. Okay, so well, I don't have any coins, but I have a bit of USDT, and right now it's checking for signals. So this cool little animation here is courtesy of Yaspin. It's a really nice addition if you're building command line apps, interfaces, programs, whatever. So you're probably gonna be here for a while. Basically it's gonna keep doing this until it finds a signal, and when it finally finds a signal, is going to ask us whether we want to place an order or not. I didn't actually code it to show us the graph when it finds a signal. Maybe that would be a cool thing to do actually. Let's just go to the coding, to the code. So entry order is the function that checks for signals on all the symbols, and if it finds a signal, then it's gonna ask us if we want to place an order. Now it would be useful to also see how the chart looks like when we're asked this, right? So let's see, what can we do? So here we have symbol data, and we have the strategy function, the pairs strategy function. So the strategy function is gonna return a boolean. By strategy function returns a boolean. So basically what we need is to create a trading model and plot the data to see how that looks like. So okay, let's try it. The symbol is symbol, and the time frame is, the time frame should be, oh, both params are interval. We want to plot data. Okay, let's try again. So I'm gonna cancel this. Now you see it didn't actually, I pressed Ctrl C and now it exited the loop, but we can either execute or quit. This is useful because later on we might say execute backtest or quit, and when we want to, we can choose between executing and backtesting. Now I'm just gonna quit. Now let's go into let's show you how the database looks like. So you have database.db, open database. VS Code is really useful because it allows us to do all these cool things to look into databases and stuff. So as you can see, I've created 3 bots so far, given them the same name, using the same strategy, same interval, 3 minute, trade allocation 001, profit target 1.012. So profit target means once we buy and once that order is filled, we're gonna place a sell order at 1.2% higher than the price we bought it at. That's profit target. And test run, whether it's a testing or a live environment, so all of these are live. Now for orders, we haven't actually placed any orders so far, and for pairs we have a bunch of pairs here. Actually we have duplicates because as you can see, each pair has an ID and it has a bot ID, right? So for a lot of these pairs the bot ID is the same. We're using all of them in one bot, in one of the bots. And symbol, whether it's active or not. So once we place an order on a pair, on a symbol, once we place an entry order, the symbol becomes inactive, so we don't actually buy until we've exited that initial order. It's up to you really if you want to add this or not. I just did it like this. Current order ID. So once we're going to place an order on, say, Neo USDT, the ID of that order is going to be saved here. And profit loss, so far it's 1 because we haven't placed any orders, so the profit loss ratio is 1. We haven't won anything, we haven't lost anything. Let's see if we get lucky and try to run it again. We're gonna execute. We're not gonna create a new bot, so it's probably gonna, yeah, there you go. So it actually it did this for all 3 bots, right? So we have BTC, ETH, USDT for 1, 2, and for all 3 bots. Obviously this is not an ideal situation. We have some issues here. What do we have here? Right, I know what happened here. So buy signal should actually look like this. It's because the buy, it's a single element, but we actually take a list here as input. So that was the fix. Let's try again and hope that it will work again. Something else is happening here. Let's see. So the buys, so here strategy function, the strategy function is right here, is MA crossover. It returns, it just returns this, so should actually give it this, and then actually let's not do that here, we're gonna do here. So if it's a buy, then this is the price, and then and then the time. And then what else does this function take in by signals? Yeah, is that first is this is the time, and then is the price. So we should switch it around. So we're actually gonna put the time first, and then this would be the price. And also let's make something here. We want to plot whatever this strategy function gives us. The indicators for this strategy function are going to be 50 EMA and 200 EMA. So we want to plot this. So what I can do is, well, I'll make something else in the trading model. So I'll also add 10 constant fast SMA, slow SMA. I'll also add this too. So I'll add 50 EMA and 200 EMA. This is not the best way to do it, but in our case, I'm just going to do it like this. I will just do it real quick. But usually what you want is for this function to get some indicator array as input, something that maybe looks like this. Indicators is equal to fast EMA, and then 50 EMA, and then 200 EMA. And basically using this list, you plot whatever is contained in this list. So you say for item in indicators, then we say if the data frame contains that item, then we're gonna plot it. Yeah, so it's gonna plot everything that appears here, right? And also if you want, for example, if you want a different colors for each of these indicators, you can actually make each of them to be a dict, and the call name would be fast EMA, and then the color is Indian red, and then name is equal to, say, fast EMA, right? And you have a dictionary for all of these indicators, right? So it becomes a lot more customizable. Fast and in here we can go for item in indicator. So now the item is going to be this whole dictionary. So if data frame contains item of call name, then here we're going to put item of call name, and here we're going to put item of name, and here we're gonna put color. Oops, item of color, I mean. And it just makes it more modular and nicer. But yeah, okay, let's give it a shot. Let's see if it works. So and it shouldn't do this one at fast EMA, because we don't have any fast EMA, so it should just do this too. Let's give it a try and see if it works. So basically we want right here, we want to, so whenever we call the plot data, we want to input, we also want to add that indicators is equal to this, right? But it gets a bit tricky, because what if we're going to use a different strategy here, right? What if we use not the EMA crossover but something else? Then we're going to need to plot different indicators, right? So that means we actually need to go into the strategy function, and when we return the signal, we're also going to return the list of indicators that we want to plot. So it doesn't get a bit more complicated. It's just we're just not going to do that now. So I'm just gonna leave it like this. Actually, I'll leave it like this because the plot data already has this indicators by default. So let's give it a shot and let's see if it works. Cool. Okay, we're in good shape. You've got two signals. Okay, it's not actually plotting those, guys. I don't know why. But as you can see, this is one of the signals, and this is another one of them. So we found on Algo BTC and XLM USDT. It's asking us if we want to plot. Why didn't it show that? Why it doesn't show the EMAs? I wanna try and understand. Indicators is equal to 50 EMA, 200 EMA. Oh, I know why. Because we're not computing the indicators here. I should actually do something else instead. I mean, not do something else. Before I plot it, I should say model.df is equal to df. So this is the data frame, and now it's probably gonna plot them as well. Let's try again. So okay, if I press yes, it's probably an error because account has insufficient balance for this request, and I can press an yes for the other one as well, and also it's going to be an error. So that's okay. Let's quit, clear, and try again, and hopefully now we're gonna see also the EMAs. Oh, there you go, we can see them. Should have actually used different colors, but that's alright. So as we can see, just here, so the 51 is below. Just here, the 51 crosses above the 100 one, the 200 one, sorry. So it's potentially a bullish sign, this one. let's see what happened before when it passed. So here it passed, and then it went up a bit, and then it went a lot higher, and then it went below. Here as here as well it passed, and then it went higher, and that's about it for this chart. So yeah, you know, in the last 1 day, 2 days, this was a successful strategy, but it doesn't mean that in the past the things weren't different. So probably it doesn't mean anything. So I'm not gonna place on this one. No orders open on 9bot. Cool. All right. Well, this was it for today, and I did quite a long. Oh, we have another one. Okay, let's see. So this has been going downhill for a while. Well, for the last 2 days. So I'm not sure if it's actually gonna be a good idea to buy here, but oh, that's quite a jump. What happened? It's a 23.3. It's almost a wait, how much? So from 23, oh, it's like less than 2%, but in 3 minutes. Okay, anyway, yeah, that was it for today. I hope you guys enjoyed, and girls, and see you next time. Bye bye.